Hello and welcome to another lecture for my class, PSYC 440/640. The class is called Experimental Methods, but is really, as you know by now, I suppose, a class about univariate data analytic techniques from a model comparisons perspective. Anyway, this comic from the webcomic series xkcd.com seemed appropriate this week because I've been having computer problems, and I suppose over a long enough timeline we all have computer problems, and they're frustrating and maybe remind us how little we really, if you're someone like me, how little I really understand about how computers really work. It certainly seemed to me this week like my computer was literally haunted, although thankfully the demons or ghosts have been exorcised by our IT professionals, and things are working a little bit more smoothly today than they were yesterday or the day before. Anyway, this class is called Moderation and Mediation. It's really just more of a continuation of some of the topics I've been talking about before, which I've generally called interactive models. And by way of an overview, I'm just going to do a review, as I often do at the beginning of my classes or my lectures. I'm going to talk more about moderation, particularly more about a way that you can conduct simple slopes analyses. And then I'm going to talk about mediation, a topic which I'll pick up further in the next lecture. So here's the review. Knowledge. Well, where we left off last time, I gave this kind of made-up example of a non-experimental design where we're using self-esteem and negative body image as predictor variables and eating disorder symptoms as an outcome variable, and we're allowing those two predictor variables to interact. And again, this is made-up data, but it mirrors, as best as I can understand, some of the theory and empirical work in the area of eating disorders research. So again, just to represent this pictographically, we've got our two predictor variables, and we're allowing that they are going to interact. That is, we're including an interaction term for them in our model. Now we can think about the relationship as one in which self-esteem moderates the relationship between negative body image and eating disorder symptoms. That is, the relationship between negative body image and eating disorder symptoms is not constant across different levels of self-esteem. You might be wondering, could it be the case that negative body image is the moderator for the relationship between self-esteem and eating disorder symptoms? Yeah, that certainly could be. I mean, we might have that hypothesis if we were working from a slightly different theory or a slightly different empirical literature. So an important thing to realize when we work with models that have more than one predictor variable, especially when we have them interacting, is we could often rearrange the players on the board, so to speak, and we should be thoughtful about how we choose our predictor variables, how we decide which one we're going to treat as the moderator, because these decisions should be based on theory, based on empirical literature, or at least based on good clinical judgment, not just we fiddled around with the different variables until we saw something that looked compelling or saw something that looked statistically significant. Anyway, assuming we had a really good reason for setting up the model the way we did, you would note here in the output of a hierarchical linear regression in SPSS that the version of the augmented model, what SPSS calls Model 2, that includes the interaction, explains significantly more of the variance in the outcome variable than the one which only includes the main predictor variables. Now it's not a lot more, it's only about an R-squared change of maybe about 3%, but that small difference is enough to be statistically significant and suggest to us that there is an interaction going on. And if we looked at the coefficients for model number 2, that is augmented model number 2, we can see that that interaction term is a significant predictor of the outcome variable, which suggests to us that the change in the relationship between negative body image and eating disorder symptoms across different levels of self-esteem is significantly different from 0. So there is a change across levels of self-esteem, and that change, although perhaps small, is significantly different from 0 change, which would be the case if there was no interaction between these two predictor variables. So again, to review from last time, if we say that there's a significant interaction, if we say that there's moderation, it's like saying that the effect of one predictor variable on the outcome variable depends on the level of the other predictor variable, what we're calling the moderator. Or if we want to think about this in kind of a geometric way, we can say that the slope of the model for one predictor variable predicting the outcome variable changes across levels of the other predictor variable, the one that we're calling the moderator. Now, I made this point last time that detecting an interaction in SPSS, that is finding some evidence, as we just saw, that there's an interaction going on, is often not really very hard to do. It just involves a few steps. What is sometimes a bit more challenging or a bit more interesting is to interpret the interaction or to characterize its nature, to ask the question, or to note that the effect of negative body image on eating disorder symptoms is moderated by self-esteem, but to ask the question, in what way is it moderated? What does that moderation or what does that interaction look like? Now, I ran through some different options last time for talking about interactions or characterizing them, interpreting them. One is a graphing approach. Another is expressing the model in terms of its interaction, writing out the regression equation in such a way as to kind of highlight the effects that the moderator variable has on the slope and intercept of that model. And a third option is to perform what's sometimes called simple slopes analysis, which is to get a more fine-grained perspective on the levels of the predictor variable at which the relationship, the levels of the moderator variable at which the relationship between the predictor variable and the outcome variable is significant, and the levels at which it is not. So let's review these options again, just individually. This graphing approach that I described is easy to do if the moderator variable is something which has a natural categorical metric. So for instance, if your moderator variable is gender, you might only have 2 levels of gender, male or female, or maybe 3 levels, male, female, transgender. The point is that there are some variables out there which we might choose as our moderators, which naturally come to us in categorical metrics or even dichotomous categorical metrics. Like if your moderator variable was, treatment with a particular drug, people either got the drug or they didn't. In those cases, it's very easy to make a graph and to just take advantage of that naturally dichotomous or categorical moderator variable. However, in other situations, our moderator does not have that natural categorical metric. Instead, it has a natural continuous metric. In the example I've used, of course, that moderator variable self-esteem, I think in most ways of thinking about self-esteem, is a continuous variable. Some people have very little, some people have quite a lot, but we kind of assume that on a deep level, this metric or this variable sort of ranges across various different values. In these situations, which we often encounter in psychology and in behavioral sciences because of the nature of the stuff we study, if we want to make a graph, we can opt to make that continuous variable, that continuous moderator variable, into a categorical variable by splitting it up. And the easiest way to do this would be to make a median split, the high group and the low group. People are above the 50th percentile, people are below the 50th percentile. Or you could make a high group, people who are at or above 1 standard deviation above the mean, and a low group, people are at or below 1 standard deviation below the mean. This approach I call kind of a quick and dirty approach. Quick in the sense that it is easy to do, dirty in the sense that it can sometimes lead to somewhat problematic or confusing interpretation. So to just really quickly repeat that point, it's pretty quick in SPSS to just bang out a new variable which corresponds to your existing continuous moderator variable, except it is categorical. That's pretty quick. Dirty in the sense that the graph can be misleading. We can sometimes get a slightly imperfect sense of the nature of the moderation, the nature of that interaction. Now, I argued last time that there's a better approach to this quick and dirty method, although I myself use the quick and dirty method sometimes as an initial pass, a first look. And that better way is expressing the model for the interaction, which is really just a matter of rearranging the model, algebraically reordering the regression equation so as to highlight the way in which the relationship between our primary predictor variable and our outcome variable changes across different levels of our moderator variable. In this case, we kind of sort through these terms, rearrange them so that we have these two parentheticals, one of which corresponds to the intercept, one of which corresponds to the slope of the so-called simple relationship between negative body image and eating disorder symptoms. And once you've done this, it's pretty obvious, I think, that as self-esteem goes up, the intercept of this model drops down and the slope becomes more shallow. So you could say that self-esteem, in a sense, buffers or attenuates the relationship between negative body image and eating disorder symptoms, or at least that's the impression we get from this this model in this data. And we can also, of course, just kind of do the math to solve for these different values and interpret them as you can see below. We can get a sense of how the relationship between negative body image and eating disorder symptoms, how the slope and the intercept for that relationship changes across different levels of self-esteem. And once we've expressed the model in this way, it's a very simple matter to plug in different values that are interesting to us to create regression equations, to create equations for lines that represent different people in the data set. So for instance, we could create a line to represent people who are one standard deviation above the mean in terms of their self-esteem, or a line to represent people who are one standard deviation below the mean in terms of their self-esteem. These are simple slopes in the sense that they're restricted to people of just those levels of self-esteem. If we plot those lines on a scatter plot that represents the relationship between our negative body image, our main predictor variable, negative body image, and our outcome variable, eating disorder symptoms, you can fairly easily see pictographically how this relationship changes at different levels of self-esteem. And choosing one standard deviation above and one standard deviation below is pretty commonly done, but really you could choose as any values on self-esteem that you wanted. The mean, one standard deviation above, two standard deviations above, or so on. I mean, in a sense, there are literally an infinite number of little simple slope lines we could draw. I just picked two that seemed pretty obvious to me, and I think would be pretty obvious to most people. So again, when we think about options for interpreting or characterizing an interaction, there's this quick and dirty approach where we make subgroups based on the data for our moderator variable, assuming it's a continuous variable. And this can create some problems for interpretation, although it's not always such a bad idea if used as a kind of a first pass. There's expressing the model for the interaction, rearranging algebraically the regression equations, which is certainly much more precise. And in a sense, we can combine these two approaches by using our expressed model to create lines that represent simple slopes, which I think of as kind of like the best of both worlds. We get the kind of the pictographic representation, which is kind of appealing and easy to understand, and we get the precision of the precisely expressed equation. So by this point, hopefully you see that it's fairly easy to do a simple slopes analysis to describe or to characterize the nature of an interaction. There's actually another option for doing this work and doing some additional stuff, and that is to take advantage of a custom macro that is written for SPSS called Process by Hayes, and it's a tool that does a lot of stuff with moderation and also with mediation analysis, some of which I'll touch on in this lecture. But because it's so, I think, so useful, and because it's widely used, and because it's free, as long as you have SPSS, I think is worth talking about right now. So let's consider moderation, a kind of a more formal simple slopes analysis using Process. Well, the first thing you need to do is get Process, which you can get from the website noted right here. I'm not sure what the current version is. I think it's like 2.16 at the time of the recording of this video, but almost certainly there'll be another one down the road soon. Anyway, you go to the website, you download it for free. It comes as a compressed or zipped folder. You extract it on your hard drive or put it somewhere in your computer. Then in SPSS, you navigate to install custom dialog. Now on my version of SPSS, that menu is, or that command is located in the utilities menu. I feel like the other day when I looked at a newer version of SPSS, that same command, install custom dialogs, was located somewhere else. So you might have to sort of search around, but it's there. As of 2017, it's there somewhere. You're just looking for install custom dialogs. And when you open up that file, when you open up that command, you should see a dialog box that looks something like this, where it's asking for the particular custom dialog you want to install. That is an SPD file, which should be part of the download for process. So that extracted folder that you got when you opened up the zipped folder from the website for process should contain a little .spd file called process. You just have to find it. If you put it on your desktop or wherever you typically extract files, select it, and then basically it should be available for you to use. And you'll know it's available for you to use because if you then go to Analyze Regression in our menu system in SPSS, as we've done now so many times, you'll see a new element there, one called Process by Andrew Hayes. I think I might have called him Stephen Hayes earlier, but Andrew Hayes, he's the guy who developed Process and has written very extensively about moderation and mediation type analysis. So if we wanted to test a moderation analysis, we'd open up Process and start to select our variables, as you can see here. My outcome variable is going to be eating disorder symptoms. My independent or predictor variable is going to be negative body image, and I'm going to call self-esteem my M variable. M in this case means the moderator variable. So make sure those variables are selected as so. Over on the left, you'll see a pull-down menu for model number. Select model number 1. That's just the type of analysis that corresponds to a simple moderation, which is what we're looking at right now. And then before you hit OK, click the button for options, and you can see here a number of different options which you can select. And I've selected a few of them here. First, we're going to mean center our predictor and moderator variable, and I'll talk about that in just a second, why we would do that and what that even means. I'm going to select homoscedasticity consistent standard errors, which is just adjusted standard errors. They're adjusted to reduce the effects of violations of assumptions of a homoscedasticity, which may remind you a little bit of our discussions of the assumptions that underlie regression. I'm also going to ask for confidence intervals, and I'm going to ask to generate data for plotting, which is available, as you can see, for model 1, which is good because that's the model type that we're running. Once you've selected all that stuff, hit OK or continue or whatever the button is that is in the bottom there. Now, before we run through the analyses, I want to briefly address something that I've mentioned a few times and just a second ago mentioned, and that is this idea of centering the predictor and moderator variables. Now, remember, there are reasons why we might center a predictor variable, and by center I mean mean center, which is to say create a new variable which has scores for each person, and those scores reflect the difference between the person's original score on the variable and the mean for that variable. So people have a positive score have scores that are above the mean. People have a negative scores on this new mean-centered variable. Their scores are below the mean. Now we can sometimes do this, or we choose to sometimes do this, to make the intercept of our model more interpretable. If you have a situation in which our predictor variable, or for that matter, our moderator variable, doesn't have a natural zero, like if we're talking about intelligence, there are no people who have 0 IQ, as much as we might joke about that. Or even age, it is, I guess, technically possible to say that someone has 0 age, the split second prior to their birth or their conception or whatever. But, to talk about age, which is a variable we often use, 0 isn't particularly useful. So if we mean center a predictor variable like IQ, or a predictor variable like age, then when we interpret the intercept of our model, that intercept refers to the prediction that the model makes when people are at the mean level for that predictor variable. So the mean level, when people are at the average age for our sample or the average IQ for our sample. That could be often more interesting or more easily interpretable than the standard interpretation, which is just the prediction that the model makes when the predictor variable is at 0. Now the new thing, or what's new now, or at least I haven't mentioned it prior, is that mean centering predictor and moderator variables can reduce multicollinearity problems with interaction terms. That is to say, the interaction term for centered variables will be less correlated with those variables than will the interaction term made from uncentered variables. And you can actually see this if you make some correlation matrices for the variables in our analysis. So here's a correlation matrix for the original variables, self-esteem and negative body image uncentered in whatever their natural sort of metric is. And the interaction term, which as you recall, hopefully is just the product of those two variables. And if you just quickly look at this, you can see quite easily that the interaction term is fairly well correlated with the two predictor variables, and this of course makes sense because it's made from, it is the product of those two predictor variables. Especially in the case of self-esteem, we can see that the correlation between self-esteem and the interaction term is really quite high. Here is a correlation matrix made from centered predictor variables. So I have self-esteem centered, negative body image, which I've centered, and then the interaction term, which is just the product of those two centered variables. And you can see almost immediately, I think, that the correlations between the predictor variable and the interaction term are much, much lower. So notice here, and this is important, that the correlations between the predictor variables themselves don't change. So the correlation between self-esteem and negative body image, and the correlation between self-esteem centered and negative body image centered, that stays the same. And that's really important because we wouldn't want to alter that correlation. But the correlations between the interaction term and those predictor variables, those go down quite a lot. And you can see that kind of highlighted here with all my little arrows. So that's a good thing. In general, high levels of multicollinearity can be problematic. It can make it harder for us to create a model, or for SPSS to create a model for us. It can make it harder for us to interpret that model. So it can be useful to center predictor variables when creating interaction terms. Again, partly to make the intercepts for the model more interpretable, but also to reduce multicollinearity problems, which is, again, this is why I selected that option back on the previous slide. Oops, it looks like I made a mistake here when I told you to go ahead and run the analyses. I should have told you to click on the button for conditioning. Do so if you haven't already hit continue or OK. Anyway, what we're going to do here is for the pick a plot option, we're going to select means, the mean and plus and minus 1 standard deviation from the mean. This is just going to give us 3 little analyses that will give us a sense of at what level of the moderator variable is the relationship between the predictor and the outcome variable significant, and at what level is it not. And actually the other option here, the Johnson-Neyman approach, is kind of like that, except just much more fine-grained. It looks at across a range of different values for the moderator variable and gives you multiple little tests to suggest at which levels the relationship is significant, at which levels the relationship is not. The output you get is not that attractive. It's kind of this old school looking SPSS output, but it does the job. It gives us a lot of the information we need. If you scroll down through your output, one of the first things you'll encounter is the model summary, and here you'll get values for the multiple correlation, R squared, the F statistic, the p-value for the model, that is comparing the augmented model to a compact model without the predictor or moderator variable in it. And it's worth noting that this is the same information that you would get if you just ran a multiple regression in the regular regression module. And you can see I've reproduced the model summary from that analysis below, just to show you that it's the same information. By the way, this is something that I do a lot in SPSS and in other stats programs. I try and do the same analysis a couple different ways, partly to check to make sure I'm doing it right, but also because I think it's a nice way of teaching myself to be flexible in my data analytic approaches. So, as a general point, or maybe like a meta point for this whole series of lectures, as you're playing around with SPSS or with Excel or even with R, try to see if you can get the same results by approaching from 2 different angles, for approaching from one module and then a different module. That idea, that approach, I think can be really helpful for learning. So with that in mind, you can see here kind of in the top right, this is the output for the model, meaning the augmented model in this analysis, and we get a table with coefficients and standard errors and test statistics for them and confidence intervals. And you can see it's essentially the same information as I got when I ran the model when I ran the analysis in the regression module. I've reproduced that table kind of in the center and lower. Now the only thing that's really different, and you'd have to kind of squint at this a little bit, is the standard errors for each of these regression coefficients, the constant or intercept and the various slopes, is a little different, and that's that adjustment that we asked Process to make for us to kind of offset problems if they exist with heteroskedasticity, but essentially the same information. Moving a little bit further down in the output, you can see the table for the pick-a-point analyses here. It's kind of up in the top. That's where what Process has done is selected values for our moderator variable self-esteem that are one standard deviation below the mean, at the mean, and one standard deviation above the mean, and then just tested to see whether the effect of the predictor variable is significant at those levels of the moderator variable. And you can see that when self-esteem is one standard deviation below the mean, when it is at the mean, then the effect of negative body image on eating disorder symptoms is significant. However, when self-esteem is one standard deviation above the mean, the relationship between negative body image and eating disorder symptoms is not significant. And just as a reminder, you can see one of the graphs that I made in our previous analyses towards the bottom of this slide, and it kind of makes sense. If someone is at average self-esteem or one standard deviation below the mean self-esteem, and they have sort of low self-esteem, the relationship between negative body image and eating disorder symptoms is significant, but when they're at high self-esteem, that relationship is not significant. That dotted line there, although it appears to have an angle, and it does have an angle, that angle is not significantly different from 0. You can actually see that if you look at the confidence intervals for the analysis where self-esteem is one standard deviation above the mean when someone has high self-esteem. Now you remember earlier we asked for that Neyman Johnson technique analysis. This is a lot like the pick the point analysis, except it's just giving us a more fine-grained look at the areas or the regions in our moderator variable where the relationship between our predictor variable and our outcome variable becomes significant. So you can see here that for levels of the moderator variable that are as low as negative 2.5 all the way up through 0, all the way up to about 1.33, 34 or so. At all of those different levels, the relationship between the predictor variable and the outcome variable is significant, but at above that level, it becomes non-significant. So it's essentially the same thing as the pick-a-point analysis, it's just more fine-grained. If you were really kind of obsessively interested in just how high does your self-esteem need to get for this relationship between the predictor variable, negative body image, and the outcome variable, eating disorder symptoms, to become non-significant, well, you have to go all the way up to about 1.5 on our self-esteem measure. Okay, and moving on, we can see here the data that I got for plotting and graphing. This is just some output data that Process gives us. All we need to do is kind of highlight and copy that information over into the syntax window, as you can see I've done. Then you just highlight it again and hit the Run button. And once you do that, you get some output in SPSS that looks a little bit like this. I've double-clicked on the graph to open up the chart editor, and I've added interpolation lines. Those are just going to be lines that are going to follow these different clusters of points, and they give us a pictographic representation of those simple slopes that we've talked about before. And again, this is basically the same thing that we've done before. And here's just one of the older graphs I made using the technique I described previously. And here you can just see all the data points, not just the data points the Process produces for us. Okay, so the significant interaction tells us that the relationship between negative body image and eating disorder symptoms is moderated by self-esteem. And our follow-up analyses, whether we did them using the quick and dirty graphing approach or the more fine-grained simple slopes analysis, or whether we used process to run an even more fine-grained simple slopes analysis, those follow-up analyses tell us about the nature of that interaction, the nature of that moderation. Specifically, that negative body image is predictive of eating disorder symptoms at low and average levels of self-esteem, but not at high levels of self-esteem. If you wanted to write up these analyses, you might write it up in the following fashion. You might begin by first describing the model, saying something like, negative body image, self-esteem, and their interactions significantly predict eating disorder symptoms. And you report the test statistic and the p-value and the measure of effect size. By the way, this is just information that we're getting from the ANOVA table and the model summary at the beginning of our regression analysis output. Just kind of an overall test of whether an augmented model that includes these predictors and their interaction describes the data significantly better than a model which includes none of those sources of information. Because we're doing a moderation analysis, I think it's also handy to first present a table for our regression coefficients. So for here we have our centered regression coefficient, or the regression coefficients for our centered predictor variable and their interaction. Of course, we get these from the coefficients table, either from our regression output, or of course process gives us the same information. I also think it's really important when presenting a moderation analysis to try and do some sort of a graph to represent to your reader, your reviewers, exactly what this relationship looks like. And so in this case here, I've just used one of the now quite a few different graphs that we've made, but you could use one from process if you preferred. You don't need to include all the data points. Okay, so we spent a while now talking about moderation. Let's move on a little bit and talk about mediation. Moderation has to do with the idea that the effect of one predictor variable on the outcome variable changes across levels of another predictor variable, a variable we're calling a moderator. It's a little bit different though with mediation. In mediation, the effect of one predictor variable on the outcome variable can be explained by or works through another predictor variable, a variable that we're calling a mediator. In this sense, mediation is really a lot more about explaining the nature of a relationship, especially explaining some sort of underlying process or mechanism, a mechanism by which a relationship between a predictor variable and an outcome variable takes place. This variable that is the mediator is at least some part of the story or some part of the connection between the supposed predictor variable and the supposed outcome variable in our analysis. And it's worth noting we care about underlying processes because in psychology and elsewhere in the sciences, we're usually trying to explain cause-effect relationships, and mediators are part of that. The relationship between a predictor variable and an outcome variable occurs through some pathway or via some mechanism. A mediator is that mechanism, or is at least part of that mechanism. And when we try to understand these relationships then between predictor and outcome variables in the presence of a mediator, we can describe a direct effect, that is, an effect that occurs between two variables, in this case a predictor variable and an outcome variable. And we can also start to talk about indirect effects. Indirect effects are relationships between two variables that occur through another one. So the relationship between a predictor variable and an outcome variable that occurs through a mediator is called an indirect effect. If you have trouble understanding what that looks like, or if my descriptions are a little bit vague, here's a simple pictographic representation. I believe I got this from Andy Field's Discovering Statistics Using SPSS textbook, but you can see here the idea of a simple relationship. We might just have a predictor variable and an outcome variable. If we want to get more complicated or more nuanced and really dig into what is the nature or the connection between that predictor and that outcome variable, we might start testing models that include mediators. And once we do that, we can describe what, if any, direct relationship exists between the predictor and the outcome variable. Is there anything that is just about that relationship alone, and what is the indirect relationship? What amount of the relationship between the predictor and the outcome occurs through whatever our mediator is. And when we do mediation analysis, when we test mediation, what we're doing mostly is just examining the strengths of the relationship between a predictor variable and an outcome variable when a mediator is present in the model and when a mediator is not present in the model. So here's just a blown up picture from that slide I showed a little bit earlier. When I showed that slide, you probably noticed the little lowercase letters. Those letters A, B, C, and C prime indicate the unstandardized regression coefficients that describe the relationships between these variables. So the letter A refers to the unstandardized regression coefficient for the predictor variable predicting the mediator, and B refers to the unstandardized regression coefficient for the mediator predicting the outcome, and C prime refers to the unstandardized regression coefficient of the predictor variable predicting the outcome variable when the mediator is also in the model. This nomenclature, or this set of letters that I've just described, really comes from a kind of a classic approach to testing mediation, at least from a statistical perspective. And again, it's about identifying these different regression coefficients and comparing them across a set of different models. In total, there are 3 models that we're interested in. One in which the outcome variable is predicted from the predictor variable, one in which the mediator is predicted from the predictor variable, and one in which the outcome is predicted from the predictor variable and the mediator variable. Using these 3 models, Barron and Kenny set out 4 criterion that need to be satisfied in order for us to make a claim that mediation is occurring. The first one's pretty obvious, and this comes from our first model, the one that includes only the predictor variable and the outcome variable. In this model, there has to be some relationship between the predictor variable and the outcome variable. And I said it's kind of obvious because clearly if there's no relationship between our predictor variable and our outcome variable, there's no relationship that can be mediated. There's no story to tell, if you will. Our second criterion comes from our second model. This is the one that includes just the predictor variable and the mediator. And here the idea is that the predictor variable has to significantly relate to or significantly predict the mediator. And this is kind of obvious as well. If there's no connection between our predictor variable and our mediator, then that particular mediator can't be the mediator for that particular predictor variable. Perhaps it's the mediator for some other relationship, but not for the one that we're interested in. Our third criterion comes from our third model. That's the model that includes the mediator and the outcome variable. And here it's kind of the same idea. There has to be a connection. The mediator variable must predict the outcome variable. If not, then that particular mediator variable can't be the mediator for the relationship that we're interested in. Maybe it is for some other relationship, but not for the one between our predictor variable and our outcome variable. Then the final criterion, the fourth criterion, kind of comes from both model 1, that's the model that includes the predictor variable and the outcome variable, and from model 3, the one that includes the predictor variable and the mediator and the outcome variable. And here what we're doing is we're just comparing that direct and that indirect effect. The direct effect is just the relationship between the predictor variable and the outcome variable where the mediator is not present. And the indirect effect is the relationship between the predictor variable and the outcome variable when the mediator is present in the model. So we just look to see, is there a difference between those two? Or is, to use the lettering kind of nomenclature of Barron and Kenny, is there a difference between C prime and C? Again, if you're having difficulty, sort of putting a picture to this, here's a picture from the textbook. That simple relationship shows us or illustrates where a C is. That's just the relationship between the predictor variable and the outcome variable. C prime is the relationship between the predictor variable and the outcome variable in an augmented model that includes the mediator as well. And if it was the case that there is no relationship between the predictor variable and the outcome variable when the mediator is in the model. If C prime is 0, if that regression coefficient is 0 in that augmented model that includes the mediator, then we'd say we'd have a situation of perfect mediation. Our mediator perfectly connects the predictor and the outcome variable, so much so that there is no more a direct effect between the predictor variable and the outcome variable. The mediator tells the entire story, if you will. That's pretty rare. What's more common is that C prime is somewhat smaller than C. So the direct effect, that is the relationship between the predictor variable and the outcome variable when the mediator is in the model, is smaller or weaker than the relationship when the mediator is not in the model. That situation I described earlier is called partial mediation. So again, perfect mediation, where C prime is 0, is pretty rare. I can't think of a single example I've ever seen. What's more common is partial mediation, where C prime is somewhat less than C. Of course, this raises an important question. How much smaller does C prime need to be in order for us to make a claim that there is partial mediation? Well, there are different ways to think about this. One kind of classic approach is to look at the size of the regression coefficients and kind of make a judgment based on the metrics of the variables. If you, depending on what those variables are, if they have metrics that are easy to understand, like numbers of drinks of alcohol consumed per week, or numbers of hours slept per night, or things which can be easily kind of and intuitively grasped, then we might say, well, the relationship, the relationship shrinks by 2 drinks per week when the mediator is in the model. That seems like a lot to us, so we're going to claim that's evidence of partial mediation. A more common approach, and maybe it's more common because sometimes we work with variables which don't have these kind of natural metrics that are easy to understand, is to look for a change in significance. That is the relationship between the predictor variable and the outcome variable significant? Well, hopefully it is. That was criterion 1 from our Barron and Kenny system of criteria. Is it non-significant when the mediator is in the model? If it goes from being significant to non-significant with the addition of that mediator, then maybe that's evidence of at least partial mediation. This is an approach that's sometimes taken. I can certainly think of examples of papers I've read that have used this approach. It is somewhat problematic because it really hinges on this idea of statistical significance. And as we've discussed in other classes, and as we'll discuss in future classes, statistical significance testing can sometimes be misleading. Coefficients, that is to say, in this case, regression coefficients, can sometimes change very little, but just enough to result in a shift in statistical significance. P drops below 0.05 and we claim, aha, statistical significance. So it's not to say you can't use this approach, but it can be a little bit problematic. In recognition of that, there are some other statistical techniques which are a little bit more fine-grained, for lack of a better descriptor, that have to do with estimating sizes of direct and indirect effects. So especially estimating the size of that indirect effect. How strong is that pathway that passes from the predictor variable through the mediator to the outcome variable? One of these approaches is called the Sobel test. And the Sobel test just basically works out that if the test is significant, the predictor variable influences the outcome variable via the moderator. I don't, just off the top of my head right now, remember exactly how the Sobel test works, but suffice it to say it exists, and Process will give us the Sobel test if we ask for it. There's also an approach that is based on bootstrapping, that is simulating data from a very large number of samples and comparing our observed indirect effect to a sampling distribution of indirect effects from this large set of simulated samples. So if I'm being a bit vague in those descriptions of Sobel test and bootstrapping, it's because it's probably a little bit easier to show you how they work. So if you haven't already fired up Process, go ahead and do it now. If not, just kind of follow along with me. Go to Regression Process, because we've included Process now. So the setup of variables is actually the same as it was when we tested a moderation type analysis. That is to say, our outcome variable is eating disorder symptoms. Our predictor variable is still negative body image, what process calls the independent variable. Our M variable is still self-esteem, but whereas before M referred to moderation, now it refers to mediation. And the distinction is made by selecting model number 4 from the different options. Those model numbers are actually just different types of analyses, and there are a lot of them that the process allows us to do. Number 4 is just simple mediation. While you're over there on that side of the dialog box, you can select the number of samples to use in our bootstrapping. I think 1,000 is the default. That's probably enough for our purposes, but you can run the numbers up even higher if you want. If you select in the options menu, you can ask for mean centers products. That's the same as it was before. Heteroscedasticity, consistent standard errors, competence intervals. You can also ask for effect sizes, which we're going to look at. Sobel Test, I mentioned that earlier, so make sure you check for that. Total effects model, check that. And you could check on compare indirect effects, but this only makes sense when you have a model that includes multiple mediators, and process will allow you to do that. You might have a situation that isn't just a simple mediation, but where there are multiple mediators that connect a particular predictor and outcome variable. We don't have that in this case, so you don't need to select or check that box. Anyway, once you've got all that stuff checked in or dialed in, hit continue, hit OK to run the analyses. The output looks a little bit, well, it's old school SPSS output, so it's not incredibly attractive, but if you read closely, you can see a lot of the information that we want. First off here, we can see down at the bottom our model number 1, where we have the predictor variable, negative body image, and the outcome variable, eating disorder symptoms. And we just want to confirm that there is a relationship between these two variables. And we can see the regression coefficient there, which we're going to call C. We can see that it is significant. If we go up a little bit further up, we can see model number 2, where we're looking at the relationship between our negative body image, our predictor variable, and our self-esteem. That's our mediator in this case. That's little letter A, and we can see that that relationship is there. It's a bit small and it's not significant. That's going to be a problem for us later on, because remember, one of our criteria for testing mediation is that there should be a relationship between our predictor variable and our mediating variable. There isn't one here, but we'll just kind of barrel on as if there was. And if we see kind of in the middle of the output here, this is the model number 3, that includes both the predictor variable and the mediator and the outcome variable. And here we can get the strength of the relationship between the mediator and the outcome variable. That's little letter B there, and we can see that that's significant. And we can also see the relationship between the predictor variable and the outcome variable in a model that also includes the mediator variable, and that's little letter C prime there. And you can kind of right away eyeballing, you can see, is C prime smaller than regular C? And it is a little bit, and part of what we're going to look at in the remainder of this analysis is how much smaller is it, and is it sufficiently smaller to give us evidence to claim that there is partial mediation for the effect of negative body image on eating disorder symptoms via self-esteem. So again, moving on in our output, we see a table of total direct and indirect effects. And of course, this is stuff we're interested in because we want to look at those indirect effects. Up at the top, we can see the effect of the predictor when the mediator is not in the model. That's our little C. And then we can see the effect when the predictor of the predictor when the mediator is in the model. That's C prime. You can see right away that's a little bit smaller. And then we get an effect, we get an estimate of the effect of the predictor via the on the outcome variable via the mediator, an indirect effect. And then we get various different estimates of the effect size of that indirect effect. And it's worth noting here, as you can see I've done, that all of these, all of the confidence intervals for these estimate for these effect sizes overlaps with 0, so suggesting to us that this indirect effect, however we choose to kind of measure it or quantify it, is not significantly different from 0. So in this analysis, you can see that it doesn't appear to be the case that self-esteem acts as even a partial mediator for the relationship between negative body image and eating disorder symptoms. And probably we might have guessed as much even before we launched into our full process-based analysis, because we might have noticed that there's no really strong relationship between our predictor variable, negative body image, and our supposed mediator variable, self-esteem. Now, a couple points to note here before we wrap up. One is that just as with our analysis of moderation, our analysis of mediation really should be based on a good theory and some specific hypotheses. We have to have a good reason for thinking that self-esteem would be the mediator between negative body image and eating disorder symptoms. And not being an eating disorder researcher myself, I'm not sure if such a reason exists, if a theory exists, but we should ideally have a theory that says people tend to have more eating disorder symptoms as their negative body image goes up, but this is because negative body image leads to low self-esteem, and low self-esteem leads to eating disorder symptoms. That would be a kind of a theory which is framed in a mediation way, and we could test a hypothesis based on that theory by saying there ought to be a significant partial mediation between negative body image and eating disorder symptoms via self-esteem. So again, we should do this, or we should have good reasons for setting up our analyses the way we do, because if not, it's very easy just to fiddle around and say, well, let's test if self-esteem is a moderator. Let's test if it's a mediator. Let's flip these variables around. Let's see if, eating disorder symptoms predict self-esteem via or mediated by negative body image. We can, if we want to, play around with process quite a lot and hunt around for a story that looks compelling and a p-value that's less than 0.04. I'm sorry, less than 0.05. What I'm suggesting is sometimes called indulging in too many researcher degrees of freedom. Researcher degrees of freedom conceptually relates a little bit to the degrees of freedom that we've already talked about, but it's an idea that comes from a very famous paper by Simons and colleagues called False Positive Psychology. And in this paper, the researchers basically demonstrated that you can come up with seemingly statistically significant results that might be interpretable by just fiddling around with the math, fiddling around with the types of analyses you do. And this is sometimes called p-hacking, playing around with your analyses until p-value is less than 0.05 and you declare statistical significance. And the reason I'm talking about it right now is I happen to fairly recently have read a Facebook post in which one researcher complained about people using process and just fiddling with various combinations of variables and various arcane types of analyses until they got an apparently significant indirect effect, and then kind of making up after the fact a theory that would explain why the variables relate to each other in the way that they supposedly do. Process, like any other tool, is just that. It's a tool. SPSS itself, or even Microsoft Excel, give us tools, or there are sets of tools for doing our analyses. The availability of our tools shouldn't dictate the types of questions we ask or the type of theories we claim to be evaluating. Those should come first, and the tools should come second to actually do the work. Another point to make right before I finish up is that the stuff that I've covered on mediation analysis using process is really just one perspective on mediation. Remember, the idea is that we're trying to talk about the underlying mechanism that connects one variable, a predictor variable, with another variable, an outcome variable, and we're choosing an additional variable, a mediator that we're saying, or an additional variable that we're saying mediates or connects the two. We're doing this via statistical operations, and sometimes these can be criticized. Sometimes researchers can say, look, this is just kind of playing around with numbers. It doesn't really tell us that this mediator is the link, or is the connection, is the underlying mechanism that explains the relationship between the predictor and the outcome variable. And here I'm really thinking about friends and colleagues I've had over the years who work in areas like neuroscience, where when they talk about mediation, they're frequently talking about particular parts of the brain that mediate the relationship between other parts of the brain. And this mediation can be demonstrated by lesioning that part of the brain, turning off an effect or turning off a relationship by destroying part of the brain or by manipulating part of the brain, as you can see in the leftmost image here, using something like transcranial magnetic stimulation, a non-invasive technique for activating or deactivating parts of the brain. Folks who do this type of work will say this is the true proof of mediation. If you can destroy a relationship by removing part of the brain, or if you can turn on and turn off a relationship by manipulating part of a brain, that's what really shows that that part of the brain was the mediator, was the link. What you guys do with questionnaire-based data and fiddling around with statistics, that's not really mediation. Well, I won't sort of fight that fight right now, but I do want to address that this is a different perspective on what it means to describe a mediation of a relationship. With all that in mind, let's wrap up. We're coming in at just slightly under an hour, so that's kind of new for me, I think. As a preview for next time, I'll just be using a class to do a little bit more practice with mediators and moderators, just to help you learn these topics and feel comfortable using them. And as I always say, thanks for watching. I really do appreciate your attention. Go make yourself a cup of coffee or espresso or something nice to relax. And when you're ready, come back because I'll probably have a new video waiting for you. All right, bye-bye.